Welcome dear students to online learning program. In the previous 5 lectures, we have learned about Kirchhoff's laws, distance bridge network, meter bridge, about potentiometer and the uses of potentiometer. In this lecture, we are going to learn about galvanometer and how to use it as an ammeter and voltmeter. A galvanometer is a device used to detect weak electric currents in a circuit. As shown in the figure, it has a coil pivoted between concave pole faces of a strong laminated horseshoe magnet. When an electric current passes through the coil, it deflects. The deflection is proportional to the current passing through the coil. The deflection of the coil can be read with the help of a pointer attached to it. Position of the pointer on the scale provided indicates the current passing through the galvanometer or the potential difference across it. Thus, a galvanometer can be used as an ammeter or voltmeter with suitable modification. The galvanometer coil has a moderate resistance, about 100 ohms, and the galvanometer itself has a small current carrying capacity, about 1 milliampere. Let's see how the galvanometer is modified to use as an ammeter. Let the full scale deflection, current and the resistance of the coil G of moving coil galvanometer be Is and G. It can be converted into an ammeter, which is a current measuring instrument. It is always connected in series with a resistance R through which the current is to be measured. To convert a moving coil galvanometer MCG into an ammeter, the modifications necessary are: its effective current capacity must be increased to the desired higher value, its effective resistance must be decreased, the finite resistance G of the galvanometer when connected in series decreases the current through the resistance R, which is actually to be measured. In ideal case, an ammeter should have zero resistance and it must be protected from the possible damages which are likely due to the passage of an excess electric current to be passed. In practice, this is achieved by connecting a low resistance in parallel with the galvanometer, which effectively reduces the resistance of the galvanometer. This low resistance connected in parallel is called shunt. This arrangement is shown in the circuit diagram. As shown here, the S, low resistance connected in parallel. Also, the construction shows the low resistance S connected parallel to the galvanometer. Thus, connecting a low resistance in parallel with the galvanometer is converted into ammeter. Let's see uses of the shunt. It is used to divert a large part of total current by providing an alternate path, and thus it protects the instrument from damage. It increases the range of an ammeter. It decreases the resistance between the points to which it is connected. The shunt resistance is calculated as follows. In this diagram, the Ig current flowing through the galvanometer from this junction point, Is current flowing through the shunt resistance S. The total current entering at the junction is I. Therefore, the current through S is I minus Ig is equal to Is. Total current entering at the junction is I. Ig is passing through galvanometer and Is current through shunt resistance. Therefore, Is is equal to I minus Ig. Therefore, the current through S is I minus Ig is equal to Is. Since S and G are parallel, therefore we can write Gig is equal to SIS. That means whatever may be the potential difference across the galvanometer, the same potential difference is across the shunt resistance. Therefore, GIG is equal to S into bracket I minus IG, as IS is equal to I minus IG. Therefore, rearranging the equation for S, that is equal to IG upon I minus IG into G. This equation is useful to calculate the range of current that the galvanometer can measure. If the current I is N times current IG, then I is equal to NIG. Using this in the above expression, we get S is equal to GIG divided by Ni minus Ig, or S is equal to G upon N minus 1. This is the required shunt to increase the range N times. Also, if Is is the current through the shunt resistance, then the remaining current I minus Is will flow through galvanometer. Hence, G into I minus Is is equal to S into Is. Solving this bracket, we have Gi minus Gis is equal to Sis. Therefore, Sis plus Gis is equal to Gi. Is upon I is equal to G upon S plus G. This equation gives the fraction of the total current to the shunt resistance. The galvanometer is also modified to use as a voltmeter. A voltmeter is an instrument used to measure potential difference between 2 points in an electrical circuit. It is always connected in parallel with the component across which voltage drop is to be measured. A galvanometer can be used for this purpose to convert a moving coil galvanometer into voltmeter. The modifications necessary are: its voltage measuring capacity must be increased to the desired higher value, its effective resistance must be increased, and it must be protected from the possible damages which are likely due to excess applied potential difference. All these requirements can be fulfilled if we connect a resistance of suitable high value is X in series with the given moving coil galvanometer. A galvanometer is connected across the points where potential difference is to be measured. If a galvanometer is used to measure voltage, it draws some current due to its low resistance. Therefore, actual potential difference to be measured decreases. To avoid this, a voltmeter should have very high resistance. Ideally, it should have infinite resistance. A very high resistance X is connected in series with the galvanometer to convert it into voltmeter. As shown in the diagram, a very high resistance X is connected in series with the galvanometer. Let's see how to calculate the value of resistance X. As V is the voltage to be measured. V is the voltage to be measured. Then V is equal to Igx plus Ig into G. According to Ohm's law, V is equal to Vg plus Vx. Therefore, V is equal to Igx plus Igg. Ngx is equal to V minus Ng into G. Therefore, rearranging this equation, X is equal to V upon Ig minus G, where Ig is the current flowing through the galvanometer. The above equation gives the value of resistance X. The resistance X, that is the high resistance, it should be connected in series with moving coil galvanometer so as to convert it into voltmeter. If NV is equal to V upon Vg is equal to V upon Ig into G is the factor by which the voltage range is increased, and it can be shown that X is equal to G into bracket NV minus 1. Comparison of an ammeter and a voltmeter. Ammeter is used to measure current. Voltmeter is used to measure potential difference. Ammeter is connected in series the circuit, and voltmeter is connected in parallel. Ammeter is an moving coil galvanometer with low resistance, and voltmeter is an moving coil galvanometer with high resistance. In ammeter, smaller the shunt, the resistance connected parallelly, greater will be the current measured. Large its resistance, the greater will be the potential difference measured in terms of voltmeter. Resistance of ammeter is R is equal to Sg upon S plus G is equal to S by N, and the resistance of voltmeter is Rv is equal to G plus X is equal to G into. By connecting a low resistance in parallel with the galvanometer is converted into ammeter, and by connecting a high resistance in series with the galvanometer is converted into an voltmeter.